we're a family adult team. We're the 3 youngest members of the presenting today.
So to begin, I'll explain how we went about approaching the problem that the competition presented. And we kind of used a systems engineering approach. We looked at everything we already had. We already had 2 robots, and we had a lot of experience that told us that the robots we had would already work for most of the stuff we had to do. So we decided that it would make more sense to modify what we already had to make it more appropriate for the tasks we had for this instead of starting completely from scratch. And so we used our 2 current ROV systems, BAV and not BOB, and we added a few upgrades to make them work better. Didn't work as well last time we used them. And then we also used a mission. Before we started doing anything, we sat down and looked at the mission tasks, and we assigned each one a point value based on how hard it would, or how long it would take to complete during the mission, and how many points it would give us, which Katie will tell you more about.
So this is basically how we start off every year. We want to make sure that we can accomplish all the tasks. So we analyze them based on how many points they're worth, also how difficult they'll be, how long they'll take, so we don't waste our time on some things, and we want to tackle the really difficult things first so we get them over with. And so we use a ranking system to do that and decide which ones we're going to do in which order. And it was a little bit different this year because we have 2 robots actually working, so we can split up the tasks. So that's how we decided that the system was adequate, by looking at the tasks and seeing how hard they would be to do with the robots we already have.
So this is the table that we came up with. You can see that every task is broken down into identifying the objects and then what you have to do with each one of them. And we looked at each of the individual points and added all up for a total of 410. And then we estimated that the total amount of time it would take would be 25 minutes. So that gave us a general look at how long the entire mission would take. Each one of the points is broken down percentage-wise by how much they're worth overall. So you can see that the life forms are obviously something that you definitely want to accomplish this year, because it's worth 55% of the points to the mission. So that's how we definitely knew that we had to make sure that the robots were capable of doing every part of the mission. So the first robot that we built in 2009 is NotBob. And NotBob is kind of different than most of the robots at the time. It uses a skull, which is a sealed compartment of underwater lights and electronics, which is it's made out of polycarbonate plastic tube, sealed with 2 aluminum end caps that are turned down on a lathe and O-rings. It uses these large bulge connectors, which were upgraded with a much simpler scheme that we used on BABs. It used a large steel frame. Steel was another different thing that teams hadn't really considered until we built this. It's thin, and when you weld it, it can be strong and small out of the way. We used ABS tubing, and you can adjust the buoyancy by filling them with water or taking water out of them. We used basic rule 1100 gallon per hour pumps for the motors. So it features 1 up and down motor, 2 forward, backwards, and rotating motors, and 1 strafing motor. It also has a motor for the claw, which is made out of a linkage and a lead screw. And that uses a bilge pump because it's a lot simpler. A lot of teams were using other motors for their mechanisms or servos, which introduces a whole new challenge of water type, making them watertight. But with this, all you have to do is add the interface between the motor and the mechanism. And for this claw, it takes up a lot of room, but it also has a large grasp, and it's very strong. The electronics the control system that it used. It had a custom board. It actually has 2 custom boards on here. They're motor controllers, and they take a pulse position modulated signal from a VEX transmitter, which was originally plugged in to these 2 drive ports. But we updated the control system, and I'll talk about that later. It originally had a temperature probe. It has 2 cameras on it right now. Another feature of the robot that wasn't seen before it was that the camera is mounted on a servo, and since the skull is around polycarbonate tube, you can actually see just fine in all directions. It doesn't distort at all. And it allows you to look forward and down at any point.
The year after NAPA, we learned a few lessons about what a robot wants to do. And one of the biggest things we learned was that NAPA was kind of too big for what it could accomplish. And also, it wasn't very powerful, especially vertically, because it only had 1 vertical thruster. So Babs was intended to be smaller and more maneuverable. And so first we took away the second camera because we decided it wasn't necessary, and just went down to 1 camera with 4 or 6 LEDs, depending what it turned out it wanted. And we also developed a new control system. It was actually intended to be a commercial product, so that hasn't really happened yet. But this is made more compact by using this board would have has a processor. Well, this one doesn't, but the one in the robot does, has a processor, and then sockets. And each socket can have a motor controller board in it, or a board for interfacing with different kinds of sensors. And this is the motor controller board, and each board can control 2 motors. So that's made it a lot more compact, so the skull could be about half as wide. And that made so the robot could be much smaller. And additionally, we added 2 more vertical thrusters. You can see there are 3, which made it much easier to travel vertically, which is very helpful in completing missions. And for last year's mission, the robot needed to be able to twist something, so we developed a new claw that uses worm drives and winches, so the claw can twist as well as grab. And one of the final things we decided with Babs was we wanted it to be cheaper. Napa was very expensive because of smaller things such as sealing wires, which we accomplished instead of using plugs. We made a simple system that just uses a hole in the larger hole, so the wire goes through and there's no ring. So it's very cheap and it's a lot easier to build. And also we made our own propellers, because propellers Napa uses are commercial products that cost around $30 per propeller. We figured out a way to make our own that costs around 50 cents or $1.
So for NotBob this year, we didn't have the controllers, the VEX transmitters that we used in 2009 were on LEND that year. So we had to come up with a new scheme for controlling it.